Good morning, all. On behalf of Kovai Kalamakkal College of Arts and Science, Kanpur, in association with IoT Academy, we welcome the faculties of Kovai Kalamakkal College of Arts and Science and the participants joined here for the first session of National Conference on Emerging Technologies in Computer Science. We would like to invite Mrs. C. Shenpagavalli, Department of Information Technology, Kovai Kalamakkal College of Arts and Science, to address the gathering.
Good morning, everyone. Sunshine is a welcome. It brings lot of brightness. Honorable Chief Guest, Resource Person, Secretary, Principal, Dean, Head of the Departments, faculty from other institutions and students. It's my privilege to welcome you all to one day virtual national conference on emerging technologies in computer science, jointly organized by IoT Academy on behalf of School of Computer Science and Kovai Kalamakkal College of Arts and Science. I welcome you all. I would like to extend my cheerful welcome to our Secretary, Dr. K. Chinnaraju sir, the person who is imbibed with a great sense of values and determinations and strove for excellence in every activity. I welcome you, sir. I would like to welcome our honorable guest, Dr. Siju George, Associate Professor, School of Computer Science and Engineering, Christ University, Bengaluru. And I welcome Dr. Asa Joseph, Professor and Dean, MBJ College of Engineering, Bengaluru, and I request them to share their knowledge with us. I welcome you, sir. I welcome you, ma'am. I also extend my heartfelt welcome to Dr. N. Mala, Principal, who is supporting and guiding us in every activity. I welcome you, ma'am. I feel glad to welcome principals from our sister institutions. I also extend my warm welcome to participants from other institutions, and I also extend my cordial welcome to coordinator and supporting team from faculty members from IoT Academy. Finally, I welcome the HODs of various departments, faculties, and participants and make this session successful. I welcome you all.
Thank you, ma'am. Let me introduce the resource person of today's session, Dr. Shiju George. Dr. Shiju George currently serves as an Associate Professor, School of Computer Science and Engineering, Christ University, Bangalore. He has a rich teaching experience of 2 decades throughout India. His educational qualification includes BE CSC, ME CSC, Masters in Software Systems from BITS Pilani, and PhD from Velo Institute of Technology. He has served as a resource person for various sessions on time and stress management, personality development and professional ethics, induction programs for students and faculty, and as a resource person for many technical and non-technical sessions. His research areas include artificial intelligence, machine learning, data analytics, and soft computing. Dr. Shiju is a distinguished member of IEEE and International Association of Engineers. We welcome you, sir, and with this, we would like to hand over the session to Dr. Shiju George. Sir, please.
Very good morning to each and everyone gathered here for this session. I'm very much delighted for this opportunity and would definitely want to share the knowledge that I have gathered together. And the topic I'm going to deal today is 3. One is responsible AI, generative AI, and the various tools that we have in the generative AI. So let us begin with the session. Why there should be a responsible. When we talk about generative AI, we are in the mid of AI and a general artificial intelligence. What does it mean? It means that we are towards developing a machine or a systems around us which has got a kind of capability. So artificial general intelligence states that our capability is going to be equal to a system's capability, or a system's capability is going to become like our capability. So definitely when we are rushing towards such scenario, it is important that we should mind one thing, and that is what is the security aspects of a human being, because we are going to completely hand over a decision-making process to the systems around us. So definitely we need to have a framework with a policy which is going to be responsible and which is explainable, which is trustworthy and equal in terms of every new technology that we build to achieve this artificial general intelligence. So moving forward, so we have the principles of the AI being a responsible AI. So the first one is like you have the anti-bias. You cannot be biased over the systems that acts uh, support one a task and is not going to support the other one. We should have a transparency over whatever system that we develop across, and it should be explainable with an accountability to each and every human resource. The privacy is another important concern because when we talk about generating various tools, developing various tools, it definitely leads to a scenario wherein our data is not protected. So privacy part is a major concern. And while designing everything over a system to make an intelligent system, human intervention is an important aspect, and it is quite important that if we hand over everything to a system, the control will be completely on the other side. And there will be definitely kind of engagement between various multidisciplinary domains also, wherein there is definitely a need of kind of connectivity and collaborations. Now, for all this, we should have a policy which should not affect this social responsibility, and for that, we should follow that policy in a trustworthy way. So we may have two different aspects. One is the ethical part and the hacking part. Now, the ethical could be done. When I say ethical, it means we are taking the responsibility with our intelligence. The same intelligence we have to embed or include to the intelligence system as well. So let us talk a little more about what make us to think about being generating a responsible AI. For that, first we need to understand where we are now. So as I mentioned earlier, that we have started with something which we call as weak intelligence, and then now we are moving to artificial general intelligence, and thereafter definitely we'll be moving towards artificial super intelligence. Now, what's the difference between these three? When we start with a weak intelligence, it's all about what we have so far. When we have started with a statistical data sets or statistical way of uh, getting a results from a source of data, and then also like with a particular uh, output, we are labeling our output, we are specific to a particular task, and then we are moving from statistical to machine learning algorithms and trying to find out trying to predict an output which is labeled, which is known to us, or which is even not known to us also, in the form of various algorithms. But here and so far, the algorithms that we were dealing with, it's all from the beginning of, it all starts from the statistics. So in statistics we have various methods like we have various tools like Vika. There's one famous SPS. So these are the tools that we are making use of. Now moving forward, we are into the ML programs. So the machine learning programs is a handcrafted programs. When we say handcrafted programs, these are the programs which are developed, uh, which are basically developed in order to ensure in order to ensure that So in order to just ensure that whatever we are planning, that will become that we can predict easily. So the handcrafted features are basically given by us only, and the output for that is also very much defined. But moving forward from ML, we have jumped to a scenario which we call deep learning. So as you can see that in this particular screen, when we say AI, it's the subcontent for AI is like ML and deep learning. So we have reached to a maximum capability of deep learning, which is taking care of not only the handcrafted features, but it also have the capability to extract the features of by its own. And that makes kind of ability to understand what all features that you can easily abstract from a huge data set or a huge database. Now, these fields were explored like anything. And when I said the weak AI, in a weak AI, as I already mentioned, that we have a kind of input and we are going to get an output, and that is completely based on some handcrafted features. That means we already define the features based on which we are going to get an output. Now, this ML has ML moving towards this deep learning with the capability of kind of imitation of a human brain. We could even find more features from a uh, defined set of data set, which could be, as I mentioned, that which could be a huge data set. Now the thing is, we are moving from a weak uh, artificial intelligence towards artificial general intelligence. We are in a race, and we are moving and very close to it. Before that, just want to make you understand that how these algorithms are built. And when we talk about how these algorithms are built, it's completely based on the requirement. It's completely based on the data set that we have. We all are familiar with these algorithms, but how these algorithms were built, that is also, we need to understand that as well. So when we talk about supervised learning, it can be categorized into two. One is regression and classification. So when we talk about a data set wherein we have a discrete value as a label, then we make use of classification algorithms. And that means, suppose we want to identify from a bag that the ball that I'm going to pick is going to be red or blue or green. We call it the discrete categorical values. So for that, we will be using classification algorithm. There comes a data set where we are talking about continuous type. Labels are continuous. That means something which changes time. So in that scenario, we make use of all different types of regression algorithms. Moving ahead from these two types of data set, we had a data set wherein we are not given with any label. That means we don't know what is going to be what is our output in terms of discrete value or in continuous value. So in that scenario, one thing that we can do, or one type of algorithm which is generated, is known as unsupervised learning. We call it clustering. So there are two methods. One is clustering and the second is association. So in clustering algorithm, what we try to find out is the pattern, rather than to target or predict some label, or to predict some label in the form of continuous or discrete value. We generate some patterns. So we make patterns, we'll get some patterns out of it. We make use of that patterns. And from that pattern, we do an analysis for the newer data. So you could see that how, based on different data, these algorithms were built. Then comes the next set of data set, wherein we don't want similar kind of data to be together. So the clustering algorithms deals with similar items to be together, but we have a kind of requirement wherein we want different items to be together. In such scenario, we make use of association rules. So then we have different types of association algorithms for that. So so you have seen that these are the 4 different types of data set based on which these algorithms were built. Now there comes a need of kind of algorithms wherein we have a data set in which some of the labels are known to us and other labels are not known to us. So in that scenario, we make use of semi-supervised learning, which again, we can make use of this classification clustering method. Now, for example, when I have a data set which is not labeled, I make use of the clustering algorithm, get all clusters. Now, when a new data comes in, I can predict into which cluster it goes. And that makes sense. So what do you mean by that? It means that you have the label data. So your model is going to train on that label data in the form of, it trains on the label data. You know, the model learns the patterns, it understands. Now, right, when we have a new data, it can be easily categorized into the labels. So a semi-supervised learning is basically for the data set wherein we have some labels to us and we want to find out the labels for other data. Then comes the most important one, which is very much into research, is known as your reinforcement learning. So in reinforcement learning, the idea is quite simple. We have a policy. We set a policy for a task in which we will get a reward or penalty. So if a system or a machine execute a program, and if it understands it made a mistake, that sequence will be stored in the data set. We call it knowledge base. Now, the next time the same situation happens, the same task is given to a system. Since it knows, it understands it, it's there in the memory, it knows. So what it does, it will not repeat the same mistake. So the whole pattern of execution and decision making is very much, the results of which is very much there in the knowledge base. So it gives an idea of what? It gives an idea of reinforcing to get a reward for each task. So this is the way the machine learning algorithms were developed. But as you could see that all the data sets, they are defined and the features are known to us. And based on those features, we will try to predict the output in all cases. But moving forward, there comes the deep learning algorithms, which are basically as an imitation of your human brain. All of you know, and no neural network concept is well known to everybody, wherein you have multiple number of inputs in parallel, and you can generate multiple number of outputs at the outset. So while moving from hidden layer from one layer to the another layer, the kind of features that is abstract at each next layer will give you an output which is comparatively much better than applying any normal machine learning algorithm over a data set. So what deep learning understands is not only the features which is known, but also the features which is not known. So we try to abstract maximum features. For example, if you have an image, and from that image, it try to extract each and every pixel. Through each and every pixel, try to abstract each and every objects and its locations from the picture, and it gives us an output. So this is, and when we talk about deep learning, it deals with huge data also, a big data as well. Now, as we are in the race from the weak AI, which is basically for the specific task, and since we have a lot of deep learning algorithms, these deep learning algorithms, when we started combining these deep learning algorithms for various tasks, apart from just generating or creating, apart from just predicting some label values, or apart from just getting massive features from the defined inputs, it also moved to a situation when we are generating contents. So generative AI deals with generation of the content. What content it generates. So when we talk about generative AI, there's so many tools that is well known to us. The basic tools that we have started with OpenAI is the basic one, as we all know, the ChatGPT 3.5, no, 4.5. We are using it actually. We have to the next level, which all deals with your text data. So some of the output which we are very much interested, apart from what all things we could do with the deep learning algorithms, is now generating something new. So what we want to generate, we basically want to generate text, we want to generate image, to generate audio, we want to generate video files, we want to generate synthetic data. So it is basically the generation. It is not just something uh, like predicting a value or predicting some future values. It's not about that, but it's about generating. So what we are trying to achieve is the artificial general intelligence. This is, as I mentioned earlier, also equal to a human capability. So we are rushing, we are moving. We are to save 50% from the VKI to your artificial general intelligence. So we are at the mid now. Now, OpenAI has given all of us the chat GPT. It has given us DALI also, which is for the image. It has given us Sora, which is basically is for the video files. So, it is all about like we human being, if we are asked to write a content, generate a content with our knowledge, we could write, we can uh, develop a content. In a similar way, we could, and if we are asked to create a image, that also we could do. If we are asked to develop some videos with set of images, we do it actually. If you're asked to make some synthetic data, which is not real, that also we could do. If you're asked to make a song, we could do as a human being. So what we want the system also to do the same thing. So to generate something new. So we are interested to generate text, image, audio, video, and some synthetic data for the experiments. Now this is, so how do we, so how many combinations you could have for all 5 domains that we said. So I could have text to text. That means I have a paragraph, so I can summarize it. I want to generate, I have the next one, say text to image. So I have from text to video. I could actually generate text to some synthetic data. So all these conversions from one to another one. So we have 5 domains. So these are the problem statements. Say for example, text. We want to convert that into a voice. It's very much. We have so many tools here which converts the text into voice. We have, say, voice, and we want to convert that into text. So we have so many tools available already that we were using it. So what is new here? The new is actually is all about little higher. What we want right now is we want an audio file. Say for example, somebody sung a song, and I'm singing a song, and that is very much in industries also. Like somebody is singing, you can modulate those voice and you can make it very clear. What we expect is we want to reach to a scenario wherein the 3 hours movie that you see in talkies, movie theater, we want to generate that movie as well. Just think about a scenario. I am going to play a role of a hero. So I have the whole story with me. I am going to, and I am going to train myself, all my images, all my motions, and I am going to put different other characters also, and I'm going to train my algorithm in such a way that the whole 3 hours movie is getting generated without me getting into the field. That means I'm sitting, I'm making use of a generative AI method, algorithms, and I'm going to generate a 3 hours movie wherein the characters will be all whom I want. So that's one example. Second example is Think about a scenario wherein a client want to get a system, complete system. Say, for example, banking system. Now, you talk about any companies, they take up that task, the project, and it may take say 1 year or 2 years of time to complete the project with a huge amount of money being spent by the client. So how could you make it a simple actually? So in future, in very near, what is going to happen is you are going to get the requirement of the client as a whole. Now we have all tools with us. Now what we are going to feed those requirements. We are making use of a system wherein there could be a rapid development prototype where we could agile method wherein everything is so much connected. You will be having a kind of feedback with the client. So we could make the entire project maybe could be in a 1 month, in a day, and we could do test on the other day. We could deploy it on the other day. So the whole scene is going to be in future. What we are going to what we are doing it. What we are doing it with the generative AI is we are making the process so simple. We could develop so many systems by ourselves, and that we could do it very fast. That is something amazing that we could do. And this is what is all about the generative AI aspects. Now, there's so many applications, as I was mentioning. And so, as you could see, we could have it the different all in education sector. You could have in all technologies. You could have it in modeling different arts, and you can develop or build your own models as well. Okay. Now, moving forward, how does this generative AI model works? So what we want is like, for example, if we are given with so many number of images. Now, the basic idea in generative technique is we have a generator which generates, and we have a discriminator which discriminates. So what do you mean by that? It means that we have a data set or a database wherein our we already we know, say for example, the image of dogs, different dogs. So in our database, we have our model with discriminator technique. It is well trained. Now the generator part will generate a fake images. Now these fake images, once generated by the generator, the discriminator has to authenticate it. So it has to authenticate and tell whether it's a fake or a real image. So this is what we were doing so far in a normal generative AI. Okay, but we have, and we call it a generative adversarial network. But we have a lot of variations for the generative adversarial network. So we will look one by one also. So the idea is very simple, that you have some inputs. When we talk about a normal ML model or a normal deep learning models, we have some data and labels, and we are going to get an output as a label. But here in generative AI, what we are talking about, you have some unstructured content we have as an input. And that we are going to convert it as a new content in the form of image, text, video, audio, or synthetic data. Okay. Now you have an input. And for example, this is one example, simple example for the Gen AI and what is not Gen AI. So when I say that it's a number that we are going to get an output or a discrete values or the class or the probability, it is just a normal non-Gen AI output. But when we talk about like processing a natural language, you talk in one language and it is getting converted and instantly in another language, we'll say that it's a Gen AI. Or it is getting, you send a text, it is creating an image, you send you send a voice, and it is creating a image or a video. So these are known as what the Gen AI output. Now, as I said, there are 5 domains wherein we can all work. So all the researchers could basically focus on the conversion. Say what if suppose I have been given a video of a movie which is a 3 hours video. Now I wanted to tailor it out. I want to make a teaser for that for say 5 minutes. So can we do it in such a way that some of the highlights of the movies could come out, and that we can publish it around. So these are the ideas which is so much getting popularized, and people are working on it. Now these are some as you can see input. If I give an input as a text, what could be the output? I mean, you can do translation, summarization, question answering, grammar correction. So as an image, what you can do, as an audio, what you can do, as a decision making, what you can do. So you can play games and also. For example, in the similar way, if you have an input, image as an input, what could be the text for that? So if an image is given, so you have to give a caption. What is that image all about? Actually, you could have a question answering thing also. And if an image is given, how can you complete that image? What do you mean by that? Completing an image. So you got a destroyed half old image. Okay. You know, how can you figure out and make it a little good, I mean, the sharper and a better one actually. You got an image, you want to improve the resolution of that, make it super resolution. So how can you increase the resolution of an image? And this is all could be done with all generative AI algorithms only. And for that, there are many tools. So we'll just move on and we'll see that how the different data that we give as an input with a foundation model could do or get adapted with various different types of tasks. Okay. Now, moving forward, these are the various applications. So as you could see that from the bottom, when we have a text, what you could do is you can create a content for marketing, sales, support, general writing, note making. When you talk about a code, now you could easily generate a code, but just by typing a prompt query or a prompt question for your code. And when you talk about image, you can generate an image which could be which you can use it for kind of marketing, or you can design something. And when you talk about the speech, you can synthesize a speech which you can use it for in an appropriate way. Also it could basically harm you also in other way, like the concept of deep fake, wherein you fake an image or you fake your voice, and based on that many frauds could happen, and that's happening also. Okay. And for video, you can edit videos also. You could make 3D models of various different types of models, and so many relevant applications of generative AI. And the tools that most of us we basically using, we are using ChatGPT 4, DALL-E is very much there right now, and Bard, now it's not Bard, but Google it is not Gemini. And there will be various tools which are basically paid. There are paid versions and non-paid versions also. For academic, one tool that I would like to suggest is Perplexity. You can note down. Perplexity is one of the tools that you can use apart from ChatGPT, which is specific. You have an option of focus. When you click on that focus in a menu bar, you can select whether you want it for writing, image, audio, video, or you want it for academics. So when you click on that academics, whatever you type, it will help you to give you content which also states that from where it is being taken. So if you are looking for some papers also, relevant content from a paper also, the citation of that paper is very much you can see in the content itself, which is generated. Okay, so Perplexity is one of the tools that you can make use of. Okay, so let us talk about the different types of generative AI algorithms. So as you can see, there are various generative adversarial networks. So how people have built this generative AI algorithms? What is the baseline? The baseline is the same as baseline is deep learning algorithms only. So when we had variants of the deep learning algorithms over the concepts with a concept of it becomes a large language model which make use of the mechanism which we call as attention seeking mechanism, which is under your transformer, and that's the way it basically works. Okay, so let us see one by one, little fast, and then we'll see that how and also the application of this as well. So the first one is generative adversarial network, which I just mentioned. That, for example, if you have a real, say, 100 rupee or 10 rupee note in your database, and you have trained it over the set of different numbers of 10 rupees or 100 rupees note, your discriminator know very well that what is the real image of that note. Now, a general for this, and then ensure that whether it is fake or real. Okay, this will carry on. So this is a baseline process of a generative adversarial network. Another example is a tug of war. When a tug of war happens, there are two teams like T1 and T2. So one actually apply a positive energy, the other one applies a positive energy against the other team. Okay, so both want to win. So it is a win-win kind of situation wherein the generator, who is a fake person, want to win over the discriminator. But it doesn't stops here actually. So there are various variants based on the application. So the the base algorithm, or the base one, is the GAN, that is generative adversarial network. We also call it vanilla. Okay, so we also call it vanilla. So you could see vanilla generative adversarial network. So this is the base model. So whatever I talked right now, it is all about that only. So here the mechanism is, it makes use of the stochastic gradient descent, and that is to optimize your generator as well as discriminator. Okay, when we compare the competitive setting between the generator and the discriminator. Okay, so this is the base algorithm. Moving towards the next one, which is deep convolutional GAN, that is generative adversarial network, is an advanced version. Okay, in this, instead of fully connected network, we have only the convolutional neural network, and it also doesn't have this max pool layer. It doesn't have the max pool layer, and the architecture of this is designed basically is to improve the stability during the training and to generate a high quality images. So if you talk about the application, it is basically, say, for fashion designing and all those things, and it is also used for object recognition. So these are the two things that we could do with this deep convolutional neural network. The third one is the conditional GAN. The conditional GAN is based on some condition. That means the generator is going to generate an output, specific output, which is based on some label. So what do you mean by label? Definitely a supervised learning. So you have a label in the form of say discrete value or a continuous value. So based on that, it does it. Okay. So a conditional GAN has got a input with a specific task. That means this has to be generated. Okay, so it is not like you are generating a content which is of your own. The system of generating is concerned, output as a one of whether it could be text, image, audio, video. Then comes the cycle GAN. So what is cycle GAN? A cycle GAN is something wherein you have one image. Okay, so it is basically a design for image to image translation and tasks with some, say for example, paired examples. Say for example, if you have one image of horse, image of an horse, you can convert that image of an horse into zebra. So a cycle GAN does change over from one image to other image. The next one is pix to pix. So it is used for a task like image synthesis from a sketch or a map. So for example, if you have a sketch or a map, from that it creates an image, complete image. So it goes pixel by pixel, and it trains on an input and output pair, and allow it to learn the mapping between the different images for the domain, for the output that you require. Then comes the super resolution. A super resolution is basically it focuses on generating high resolution images. Suppose you are given with the image which is a very low resolution. So it makes use of a simple deep neural network with an adversarial training, which enhance the image quality. Okay, and it is highly used, and all of us know that basically a medical image sometimes you won't get a good image. So those images could be you can super resolute that those images, or even when we talk about a satellite image, sometimes it's not clear. So we can increase the resolution of that. The another one is the progressive growing GAN, generative adversarial network. So what do you mean by that? It means that there is a progression over the training part. There is a progression over generating an output. So you are given with an image. Now see, this image is of say size 4 by 4 only. Okay, so with a very low resolution. Now with this particular technique, what we can do it, we can get a desired size of 1024 and cross 1024. That means if we can increase the resolution pixel by pixel, adding layers by layer, and say see from 4 cross 4, it's a very small size actually, which is small resolution, low resolution image. We can convert that into a high resolution image. Okay, so then comes your the next one is the style GAN. That means you got some image which has got different versions also. You have some images, and these are style GAN is basically is developed by the NVIDIA only. And what it does, it controls the image at different levels of its work. So if you are getting an image, it can give style. You can see a lot of tools in the web as a web application also, wherein you are given with an image. Okay, your own image. You upload your image. You could see that you can make changes to your image. You can make yourself smart, handsome, and you may look good also with various by adding property to your images. So style GAN is basically for that. Then comes the next one, which is basically used for big GAN. It is for the high quality images with greater diversity. So when you talk about it, it emphasizes on a large what do you say, the large batch size during the training part, that is when the model trains to enhance the performance. Okay, and you see the various the basic application is to generate a high fidelity images across multiple categories. It could have a multiple categories. Then comes the info GAN. It is it is an extension for our traditional GAN, and it introduced the latent variables that captures the interpretable features. That means the features that a normal deep learning algorithm make use of to abstract information from an input, which could be image or a video. Now for that, we make use of this info GAN. Okay, then is Western GAN actually, WGAN. There are two variations also, and what it does, it works on distance as a loss functions, and it provides a more stable training process, and it could do it. And when we talk about the application, it is particularly beneficial in scenario where training stability is very much concerned. And the last one, the variant of your GAN is these are the spatial GAN. And spatial GAN is again a spatial aware image generation task. It does the image generation task. So it incorporates the spatial information into the into the traditional GAN framework, that is generative adversarial, to improve the output quality. And it basically focuses on generating images that maintains the spatial coherence, and it make it suitable for application which requires attention to spatial relationship with the images. Okay, so these are the various variants. Okay, not these, and there are many others also, but these are the main which is being used whenever you find different tools. In those tools, these are the different variants of generative AI techniques which you could see. Okay, so let us see the next algorithm, which is known as variational autoencoders. I will make it a little fast, but I make it very clear also. So autoencoder, what do you mean by an autoencoder? There is an input. So what the auto encoder does is you're giving an input, it gives the output also the same input only. But what it does, it at the mid, it it encode first from what the job of the encoder is, when you give an input, it encode it, compress it, and from there, uh, at the output, it decode it. Okay, so two things are happening here. One is you're reducing the dimension of the input, and the second one is it learns the maximum feature out of it, which is a deterministic feature, and then it gives us an output. Okay, so this is what it does. Now, but what's the difference between normal autoencoder and variational autoencoder? The variation, variational autoencoder does it, it enables to generate new samples. Say, for example, the best example is you are giving some images of, say, for example, cat, okay, or a dog, say dog. Different images of the dogs are there in the knowledge base, and your algorithm, your variational autoencoder algorithm, is going to get trained on those dog images. So once it get trained, the output that you are going to get the image of the dog only, but you will find the dog image which is not present in the database. It is going to look something. It is a dog only, but that image may not be there in the in the data set. So how it does it? It makes use of the probabilistic latent space. What does it means? It makes use of all the uh, data, I mean the dogs image data which is there in the knowledge base, and try to understand the features and make use of that features uh, to generate its own content. And therefore only we call it variational autoencoders. Okay. The next one is all about the transformer. So what is the job of a transformer? And all LLM models basically make use of the transformer. So the GPT, which is well known to everyone, known as generative pre-trained transformers. So we have transformers, the pre-trained transformers, and the job of that is uh, to generate content from the existing content, or to generate content from generate new contents, which is based on your inputs. So how does it work? It makes use of an attention mechanism. So, for example, suppose we have say 100 images of cats. Okay, so all the 100 images of the cats are not going to be useful during the training process for your algorithm. What does it mean? It means that there will be images out of this 100, and the poster of which may not be giving you a kind of maximum information to understand what it is or what it is. Say, for example, you got a back image of a cat, side image of a cat, where the head is not known, it is not visible. Okay, so or you have in such scenarios, these information, when your transformer goes, when the input goes, when these 100 images go pass through your neural network, in the middle layer, in the hidden layers, we make use of the hyperparameters, and these hyperparameters ensure that, with an attention mechanism, ensure that the images which are not very much relevant should be taken off. We are going to drop these images. So we'll drop these images which is not going to, which is not very, which is relevant, but which is not very important to give to support the output. So those images we won't take into consideration. So it means that when we are not taking that into consideration, the images which are clear to you, so the model will make use of it to get it trained. Okay, and that is basically is known as attention mechanism. Okay, so we have the different variants of the models, transform models. We have GPT, BERT, T5 as well. Okay, now this is the whole process, the mechanism which is taken from the resource data science dojo. And you could see that there are multi-head attention. So when you have an input, you can see on the left side at the bottom, and this is a kind of, we are giving as an input, so that is getting encoded, and this is the output that you are going to get. So each layer, you could see that there are multiple head attentions over each inputs. So all these inputs, and you can further, when you zoom it out, you could see that there are different layers which works on it to scale down, to find out the maximum characteristics out of it, and what is important will be taken care, and what is not important will be dropped out. Okay, so this is the method of the transformer architecture, or the transformer generative model. Next comes the most important and very interesting one, is the diffusion models. So when we talk about diffusion models, we move a little forward from the text. We talk about the images. Now DALI 2, which is OpenAI, and a stable diffusion, it deals with the image generation part. So let us see a simple example to understand what is it. So we have a diffusion method wherein we have a forward method as well as backward method. So what do you mean by that? So please look at this image. As you could see that the image of a dog. Okay, there are other examples also, but just focus on this image of a dog. Now I'm taking the upper part here. Now you see a clear image of a dog. So what we are going to do is, in diffusion forward method, we are going to add noise. We are going to add noise in a constant rate. So I'm adding a noise at a constant rate. I've added little noise. You can see it became little bird. Again, I'm adding noise. Again, I'm adding noise. So I'm going to add noise continuously until the image get disappeared. Now you can see I have only pixels here. I don't have an image here. Okay, but the sequence is being learned by the algorithm. Now the algorithm knows that how much of in noise when I add, it will lead to an image which is completely blank. Only pixel values are there. Okay, so this is forward diffusion method. Now we'll go back actually now from we are going backward diffusion. So backward diffusion is what? So I have this pixel image with me. Now the system your algorithm it has already learned the sequence to reach to this particular image wherein you have only pixels. It has learned the constant addition of the noise. Now in backward diffusion method, what it is going to do is it is going to remove the noises in a very constant, in the same similar constant way. So the way we added the noise, in a similar way, the noises will be removed. So okay, so in each step the noises will be removed and you get back the image. Okay, so this is the way you blurred an image, and then you can get the image back also. Okay, so that method is known as diffusion. Okay, so for forward diffusion method, we'll make use of a Markov chain method. So what do you mean by Markov chain? A Markov chain is something like this. So this particular image, the first image is dependent. This is known as current image. From the current image, you can generate the next image. Okay, now this became the current image. From this image, you can build this next image. But you cannot build this particular image from the first image. That means if this is a current image, the next image cannot be developed from this particular image, the previous images. Okay, so what do you mean by that? It means that the next image is dependent on the current image. Okay, so this is known as Markov chain method, which was old method. Right now what we want the next image or coming images should be dependent on what the previous image is. So therefore only we have various different other deep learning algorithms like recurrent neural network, we have LSTM, we have GRU. So those algorithms basically ensure that it has got previous data to get the next data. So the Markov chain method was the older method, but it has got its importance here, as you could see, how we can utilize this. So if you jump from this to this, the information will be lost. Okay, so if you want to regenerate from this to this, you may not be able to do it. Okay, now for the backward chaining, we'll make use of backward diffusion method. We'll make use of CNN UNet. Okay, so convolutional neural network that we'll make use of. Okay, next comes, as I just mentioned, that to avoid, so Markov chain is used for specific different applications. So, but our need is what? Something from the previous, we should get the next word. Okay, so for example, if a paragraph while writing, typing in your Gmail or in a mobile, you could see that the next word automatically comes. It comes based on the context. So it is based on previous words that you write. Okay, so we just make use of the previous word and then we are typing the next word. So a recurrent neural network is something which makes of your previous data and then uh, based on that you get the next data. But it doesn't have that memory capacity. So it won't take up, say for example, if you have 100 lines of, if you have 100 lines of paragraph and you want to predict the next line, so it may keep the previous lines from 95 to say 100. It may not keep all the initial, I mean, lines from initial points, say 1 to 94 or 99. Okay, so it doesn't have that much of memory actually. So, but and it has got a drawback also. The drawback is known as what? Vanishing gradient problem. You might have heard of this, or exploding problem. Here in vanishing gradient problem happens. So what do you mean by that vanishing gradient? Okay, so for example, you started from an input in a neural network, you reached to the output, and in output you found there is an error. So instead of say 100, you got 95. Okay. 95. So there is an error. So I have to come back actually. I what I do is I do back propagation. I take the differentiation. I'll check the weight of each node and the bias with respect to the inputs in each node. So I'll take the differentiation. I'm going back. I'll adjust the weight. I'll try to again move forward. When I move forward, I'll get back to my final image. I mean final output. So while doing that, say for example, if you have an input and the output in between, you if suppose you have 8 layers. Okay, so I've started from the output, which is the 9th layer. I will be maybe able to reach up to the 3rd layer in backward propagation. While doing it, I'll reach to the 3rd layer. The first and second layer is not considered because in the 3rd layer itself, it got vanished. What got vanished? When you are doing a back propagation, weight is adjusted in such a way that now you move forward, you get the correct output. And it got vanished at the earlier stage actually, and without moving to the first layer and the second layer. So what happens suddenly? You know what is getting happen here, since the first and second layer is not considered, both the layers are not considered. Up to 3rd only is considered. We won't say that the algorithm or the output is correct. Okay, even though we are getting say 100 from the 3rd layer onwards. So this is known as vanishing gradient problem, an exploding problem. And why it happens? It just happens because of the reason that when you take the differentiation of the smaller gradient value from the end towards back, every time you are doing a multiplication with the differentiation gradient with the input and the change of input input and the change of your weights. So every time what is happening is you are having a value of say 0.003 001, then you are multiplying it again with 0.0. So again it is going down only, it is coming down only, right? Exploding is one wherein your value at the end differentiation is more. So say 1, it is becoming 1. It is now anytime you do a difference, you're going back actually, it is increasing only. So it explodes. Okay, so both the way it is not. And exploding problem happens just because of the reason that you random, all weights are initialized randomly only. So if you take a weight value very high, this will happen. Okay. Next comes, say for example, okay, so there are various variants of, just make it fast, various variants of this recurrent neural network. So based on kind of cardinality, say 1 to 1, 1 to many, many to 1, many to many, and many to 1. So let us see the first example. Say you are giving one input, which is say ECG. So you got a ECG value. I just want to predict whether it is normal or abnormal. Okay, so it is 1 to 1. Say 1 to many. You have an image. Okay, so this is just an image. I'm going to get a complete text, which is say this is 1 to many. So just one image, with that I am going to get a text which is multiple words. So that is 1 to many. You can see it is forward actually. An image is given and it is the sequence of words. Then you are saying that you are giving input with multiple words and you are trying to get a output. Okay, so somebody writing about say in social media, you are writing some sentences about a movie. So we just check whether it is positive or negative. Okay, so many sentences with that one. But many to many has got two timeline. I mean, so these are all time series data actually. So you have, for example, you have a week temperature here. You can see a week temperature is here. For this is the current one, previous to that also. And from there you are generating next value, that is tomorrow, the day after tomorrow. Okay, so that is actually is many to many. This is times series actually. Then next, English to French. Say for example, you give some text, and the output of that you could see that many English, you're giving English, and from English you're getting French. Okay, just conversion. So as you can see, word by word it is getting converted. So you give an input here, you got an output for that. So I am giving say I. So in German language, what do you mean by I will be you get here. Okay, so that is recurrent neural network. When you talk about LSTM, you have three main gates. Right? Forget input, output, and LSTM LSTM stands for long short-term memory. So it keeps more value. So as I mentioned that if you have 100 lines of sentences, it keeps say all 100 lines and whatever it needs to forget for the next line. Okay, it cannot keep on because it also has got a limit, but it can keep more number of uh, previous data. Now, and the disadvantage of this is you have multiple gates here. Okay, since because multiple gates are there, the computation is going to be little tough and complex. I mean, time consuming. So there comes the next one, which is known as GRU. So we use LSTM GRU together only wherever it is required. Where you require GRU, we will use GRU. Where you require LSTM, we require. They are equal. They are equal in all sense, but little differences this computations part only. So here we have a reset and update gate. Okay, so what we need to forget, what we need to remember for the next sentence, that will be taken care by this reset gate and update gate. Okay, so there are many versions of different these three actually. As you would see, there are different versions. I'm not going into the depth of this. The slide will be shared. You can go through it. Actually, there are multiple hybrid algorithms people have made for different mechanism actually. So some of them are here, which you could make use of it. Then comes the neuro style transfer, which I've already mentioned. That suppose you have an image, something like this, so you can change that image into a stylish, into some artifact form actually. So there can see so many images on the left side. On the right side, you can see kind of animated kind of images, right? So that is basically is the function of the new style transfer method. And you can see the different use cases here. Next comes the auto regressive, which is same as your GPT only. In GPT, generative pre-trained transformer. That is what is your auto regressive method actually, and it is also a pixel. The example like pixel convolutional neural network, that is for image generation, and WaveNet, that is for audio synthesis. So it is auto regressive. Okay, so model that generates sequential data. Okay. So this is, as you can see, this is connected to the next one. This is connected, and so it's a sequential data. This is non-sequential data. Then comes the flow-based data models, and this is for the image generation. You do data compressions and generation from other high-dimensional data also, and it is invertible transformation between data and a simple transfer. For example, you can see there's an X, there's a flow. And the inverse of that could basically give you X. So here comes input, it gets changed into different form, and again you are inversing it to get it back. Okay. Then conditional, which I've already explained, wherein I have some labels. I'll make use of that label as an output, and based on that only I'll create. Okay, so this is not going to generate an output of its own. We are giving some conditions, we are labeling an output, and based on that it gives an output. Okay. And this is the most important one, which is known as a retrieval of augmented generations. What it does is, so how ChatGPT works, all of you might be knowing that a large language model is there actually. Okay, so it is pre-trained actually, trained over so many resources, and it makes use of that to generate new data. Now, this retrieval augmented generation, we have a retriever in between. So what does it mean? You are giving an input. You want to ask a specific question about a particular medicine. Okay, and now the resource is at one point. Okay, so what we do is at first stage, what we do is we try to uh, get the information. We do the retrieval of the information. Okay, not the specific output that is required by us, but we try to access that large database or a private database, and then we take that, encode it, and we make a document, retrieval document out of it, and then after that we make use of a chat GPT. Okay, then we make use of a chat GPT over it. As you can see, we make use of a chat GPT LLM model over it, and then we'll get experience the most appropriate answer out of it. Okay, so we ask questions, we look into the web actually or anywhere in the, take those resources, make a retrieval document actually, we apply that LLM, and then we'll get a output. Okay. And there are, as you can see, there's so many use cases for this for generative AI. Okay, so this you could actually see the slides. Okay, now that is all about the generative AI. There are a few educational tools that all of you can make use of it. These are for different purposes. I may not be taking one by one because of 5 more minutes. So these tools we could basically use for your education purpose also. If you want to make some slides, you can make use of Presentary, Wondershare.com. Perplexity, I said, is very important for the academician. I mean, those who are doing research, please make use of it. If you want to generate from resume, basically, you can make it. There are so many tools right now available, but these are some of the important tools that we can look into. As I mentioned, there are different domains that you can create out of five different domains. You can have different combinations. So there are some open sources which are paid and non-paid also. Open, both I have included. For your reference, you can go through it. Suppose if you are talking about text generation tools, what are the different text generation tool which is open source? Professionally paid tools are there. What are those tools? You can go through it. Similarly, a text to image generation, if you want to get some kind of open source as well as paid versions, you can have it. So text to image. Then we have text to video. You want to create a video. So what are the open sources? What are the professional sources? Then text to audio and audio to text. These are the different other tools that we have. So these are kind of small bit research I did in order to find out and experience. Some of them are really good actually, but most of them after a few trials is a paid one actually. So you have to pay for that also. But if it is important for your work, any work actually. So for example, if you want to create some good image, so definitely make use of this DALI or this Midjourney to make those images, high quality images for your research work as well. Okay, then you have image to video, then you have video to video generations, which is open source as well as professionals. Okay, and then you have presentation slides. You want to make a slides presentation. There's so many tools. Okay, you give you basically give your title. I mean, the title, I mean, say deep learning, it will create, and you ask for say 10 slides to be generated, 20 slides, it will generate 20 slides for you. Okay, then you can edit, you can do whatever you want, Canva, free versions. So these are some presentation slides that you can make use of it. Okay. Now with this, I'm ending my session. Thank you very much for listening to me. So in short, the final conclusion is something like this. So far we were living with weak AI, and so weak AI and strong AI. We are moving towards strong AI. So what do you mean by weak AI? Weak AI is very specific. You have some specific tasks. Okay, you are given with a specific task. So we make use of machine learning model. We make use of the statistical methods. We make use of machine learning methods, and we make use of the deep learning methods to fulfill or to get that desired output. Okay, so this is what we were doing so far. Now we are moving from this weak AI towards artificial general intelligence. Okay, so we have developed generative AI, Gen AI methods. So the different algorithms we have seen. So we make use of those algorithms to reach to this particular intelligence, that is artificial general intelligence, which is of a human capability. So everything around us, as we can make decisions, right? Still, if you ask me, systems are not as capable as a human being. We could do things much faster than systems also. I'm not saying in terms of computations actually. Your movement, your gesture, you're making any decisions while driving and all those things. Say when we say self-driving cars, there's how many components are there, right? So, but for us to make a decision actually, okay, and we are into that actually. See, autonomous vehicle is a big research area actually, wherein we are not only emphasizing on different modules of that driving the car actually, but we are also giving a kind of importance to the different drivers, the behavior of the drivers, the way they drive and all those things. So that patterns also we are trying to understand. But when we talk about as a normal human being, we are artificial general intelligence. We are already in that actually. So we want, but the Gen AI is helping us a lot to make a system around us which make a decision in order to reach to this particular situations. Okay. Now that is the mid part, which is artificial general intelligence. The last one is artificial super intelligence, which is beyond or above us human being. So if we are able to create in next 20-30 years the system which is known as artificial super intelligence, they are going to lead, I mean they are going to superpower on us actually, because their capability is above our imaginations. So they will do things which we cannot do. Okay. So this is all about the presentation, and I'm really thankful to the audience. And to contact me, one more thing, to contact me, you can mail me to. I'll put in chat box my email ID. You can contact me this email ID for any queries, for any research help, because I'm also doing a lot of research based, because we could identify around 42, because as I said, there are 5 domains, so including the synthetic data that we create, and based on that, we are able to 42 statements we could write, out of which 20 we are working on. We have many students who are working on it actually. So any supports or anything that you would like to know about it, you're most welcome for that actually. So thank you so much. Once again, I thank the college as well as the IT Academy for giving me a wonderful chance to interact with the audience. And I hope that this was a short span of time, and I hope that with a very short span of time, you could understand where we are moving. We are moving towards artificial general intelligence, and then from there to artificial super intelligence. Thank you so much. Okay, so thank you so much to the audience. Thank you.
On behalf of Kovai Kalaimagal College of Arts and Science, Coimbatore, in association with IoT Academy, we would like to extend a heartfelt gratitude to our esteemed resource person, Dr. Shiju George, for taking the time to share his valuable insights and expertise with us today. We are grateful for your willingness to share your knowledge and experience with us, sir. We thank you very much for your efforts, sir.
Thank you, madam.
Asha, ma'am, shall we start now?
Yeah, I think we can start.
Yes, ma'am.
Shall I share the screen then?
Yes, ma'am. Good morning, all. On behalf of Kovai Kalaimagal College of Arts and Science, Coimbatore, in association with IoT Academy, we welcome the faculties of Kovai Kalaimagal College of Arts and Science and the participants joined here for the second session of National Conference on Emerging Technologies in Computer Science. Let me introduce the resource person of today's session, Dr. Asha Joseph. Dr. Asha is currently the Dean IQAC and Professor at MVJ College of Engineering, Autonomous in Bangalore. With over 27 years of experience, Dr. Asha has held various roles in both industry and academia. She has contributed in various capacities such as Dean, Professor, Head of Department for Computer Science and Engineering, Artificial Intelligence and Machine Learning at different institutions in South India. Dr. Asha is one of the research supervisors of APJ Abdul Kalam University and Vishweshwaraya Technological University. She has numerous publications to her credit in the field of computer science, which includes book chapters, journal papers, and conference papers. She also plays an active role as a reviewer for prestigious journals and international conferences. She is a senior member of IEEE, a life member of ISTE, and member of National Cyber Safety and Security Standards. Dr. Asha has actively participated as resource person and session chair in numerous webinars, workshops, seminars, and conferences. We welcome you, ma'am, and with this, we would like to hand over the session to Dr. Asha. Ma'am, please.
Okay, thank you. Yeah. Let me directly get into the presentation because I don't have that much time left now. Okay, so hope my screen is visible.
Yes, ma'am.
First of all, let me thank IoT Academy and Kovai Kalaimagal College of Arts and Science for giving me such a wonderful opportunity to give a keynote in Monday Virtual National Conference on Emerging Technologies in Computer Science. So the topic which I have selected is Digital Phenotyping, Unveiling the Digital. I'm just directly going into the topic. What is digital phenotyping? Before understanding what is digital phenotyping, you need to understand what is digital footprint. As we all have the fingerprint, similar way we are leaving digital footprint whenever we are using the different types of electronic gadgets. So what's our digital footprint? So every online and mobile activity, it leaves a trace. So these are some of the examples. Whenever you are posting something in social media, whenever you are using some app, and your location data, your online transactions, your search history, all these are the different digital footprints, examples for digital footprints. Let me go to the history of digital phenotyping. It is conceptualized in 2010, combining the data science with the behavioral health assessment. It has emerged from the need to objectively quantify behavior using the data from smartphones and wearable devices. So digital phenotyping and behavioral biometrics have emerged as transformative technologies for mental health assessment through the smart devices or mobile devices. So there are some different tools that leverage real-time data from smartphones and wearables to monitor behavioral and physiological patterns. They offer valuable insights into mental health conditions. So, however, these advancements, they also bring significant security and privacy risks, including the data breaches, unauthorized access, manipulation, and device compromise. So the early concepts, before getting directly into the digital phenotyping and smart wearable devices, the early research on using technology for behavioral observation was something which is known as ecological momentary assessment, EMA. When at that time they were using, maybe in 1990s, 1997, 98, that period, it was the more famous or more popular one was the pager. So early research methods involve real-time data collection on individuals' behaviors and experiences in their natural environment. So use of pagers, you can even say, before smartphones, devices like pagers were used to prompt individuals to report their current state of activities and even providing snapshots of behavior in real time. Introducing digital phenotyping. So we can even say what is the definition of digital phenotyping? So the definition says that the moment by moment quantification of the individual level human phenotype using data from personal devices. What is the key idea behind it? The key idea is turning the passive data into actionable insights about behavior and health. What are the different applications of digital phenotyping? The main, I have already mentioned some of the applications. The main three different main applications are monitoring mental health, tracking physical activity, predicting disease onset. So these are the applications of digital phenotyping. And we can say for implementing the digital phenotyping, we are actually using the ML machine learning algorithms. Those kind of algorithms are actually explored to enhance anomaly detection and ensure secure data handling. And what happened in the smartphone revolution? So you can say the proliferation of smartphones introduced powerful portable devices equipped with the multiple sensors. And the modern smartphones, this can collect data on location or any movement which you are doing and your orientation itself, and which can enable continuous and unobstructed monitoring. Now, the current trend, the rise of big data and AI. The confluence of big data analytics and machine learning, the big data analytics, if I talk about, the vast amount of data generated by digital devices that necessitated the development of sophisticated analytical tools to process and interpret information. Then comes to the artificial intelligence. Machine learning algorithms can identify patterns and make predictions based on complex data sets, enhancing the potential of digital phenotyping in healthcare and research. What are the different techniques we use to implement the digital phenotyping? First one is the passive data collection. Next comes active data collection, wearable sensors, data collection from the wearable sensors, smartphone usage analysis, behavioral analytics. So you can say the rapid adoption of these mobile health technologies, it has revolutionized healthcare delivery with the digital phenotyping and behavioral biometrics, which play a pivotal role in mental health assessment. So the digital phenotyping collects passively generated data from mobile devices such as GPS tracking, app usage, and even your typing speed, while behavioral biometrics analyze unique user interaction patterns like swipe gestures and even the typing speed or typing rhythm. So together, the digital phenotyping and behavioral biometrics together, they offer real-time objective insights into mental health status that actually enables early diagnosis and maybe if treatment is necessary or not. And despite this potential, these technologies such as digital phenotyping and behavioral biometrics, they introduce concerns into security and privacy. So the sensitive data, whatever data you are giving, your data is being received by the other end. If it is mishandled or compromised, it can lead to identity theft, privacy violations, and misuse by malicious people. So what are the different techniques and data sources which actually are the parameters which may be considered for the purpose of collecting the data? So we can see in each and every smartphones, wearable devices, they have the GPS, they have the accelerometer, they have the gyroscope, microphone, light sensor, proximity sensor, and barometer. And the usage data is also being collected. You can see once every week your phone is saying your phone usage, your net usage, your app usage. This you will be getting a statistics, right? So the app usage or call logs, your SMS logs, your browsing history, keyboard input, all these are the different techniques, or all these are the different data sources. And how exactly it is being taken. So the first one, if I talk about the GPS, that tracks geographical location and movement patterns. So you are carrying your mobile and visiting some places, and you are going for a trip, taking some photos. Even if suppose you have opened your mail in the phone, next within a week you can get the place of the location of this person in the previous 1 year. All the different location you have visited, that may be it is actually you can see the photos, even the photos you have taken over there, that will be added. It is being included in the database which you are going to watch later. Comes when talk about the accelerometer, measures acceleration forces indicating your physical activity levels. Gyroscope detects orientation and even your rotational movements, whether you are jumping, whether you are tilting your head. whether you are sitting in a reclining chair. So such kind of orientation is also being recorded. Microphone, it captures all ambient sound which can be analyzed for social interactions or environmental context. Suppose if I am saying sitting in front of my mobile phone, I am saying about, okay, PVR cinemas. Next, the recommendation system will give me an output saying that the cinemas which is played, the movies which is played in PVR cinemas this week is this particular movie. So that means whatever you are talking, it is all being recorded. And light sensor assesses ambient light exposure potentially relating to sleep patterns. So if you are sleeping with your smart wearable devices, your wearable smart watch, right, it is even identifying your sleep pattern, whether it is you had a sleep, light sleep or a deep sleep, or this particular period of time, whether you were not sleeping. Such things are also being identified. And proximity sensor detects the presence of nearby objects useful for determining device usage patterns. Then comes the barometer. It measures atmospheric pressure, aiding in determining elevation changes. I'm coming back to the usage data. This is what most of the people are interested in. So your app usage, frequency and duration of your app interactions can indicate habits and preferences. Most of the time, suppose if I am stressed, what should I do? What will I do? If I'm stressed, I may be opening one music app and maybe listening to that particular music. So that is from that, if somebody is analyzing, right? This is what usually happens in real life also. If one person is talking to you, watching you, observing you, so easily they can make out your habit, right? Similar way, it is like now the artificial intelligence have grown into such a stage using the smart wearable devices or smart devices which is in your hand. It can even analyze, it can even identify your habits and your preferences. And according as per your preferences, the AI, the artificial intelligence, it is giving you the recommendations. The recommendations are given to you. Best example is, suppose I am watching a comedy movie this week continuously. Next week also, it will the system will say you, okay, you are into your type of movies. That is, you might have already familiar with that. So here, this is what is happening. The frequency, the patterns in your communication can reflect social connectivity and support networks. And then browsing history. Even if you have cleared your browsing history, it reveals interest in information seeking behaviors. Then comes the actual keyboard input physically. So the typing speed and patterns may provide insights into cognitive function and even your mood. So one of the digital phenotyping application is monitoring behavioral changes, which is indicative of mood disorders, or it can detect early signs of anxiety or depression. It can even provide clinicians with continuous behavioral data for better treatment plans. So those are some of the applications which comes along with this digital phenotyping. And talking about data sources once again, wearables. So all of us are much familiar with the wearable devices now. Everyone is, I think, almost everybody is having smart watches, smart clothing, and which is having the biosensors also. What are the different data collected using this wearables? Through these wearables, the heart rate, your activity levels, your sleep patterns, as I have mentioned before, your skin conductance, your body temperature, and even your blood oxygen levels are being now it is being measured, analyzed. And what are the different devices? We can say there are fitness trackers. This is what I have shown in the images. The fitness trackers obviously monitor physical activity, steps taken, and even the calories burned. So people will be very happy to say that, okay, this is the particular app which I am using, and it shows me the how much of the calories I have burned this week by walking, or how much of the calories I have burned by doing my maybe Zumba dance, right? and I'm happy. And even my system is actually recommending me to use this for go for another 10 minutes of walk, so that you can your health will be much better. But when you are doing all these things, when you are doing the using the app, when you are using a particular device, you are not even knowing that you are being actually closely monitored. The smartwatches, it can track heart rate, sleep patterns, and can integrate with other health apps also. Even the health apps which you have not even preferred, that could be taken and into, and it can integrate. Then the smart clothing, embedded sensors in clothing can measure physiological metrics like muscle activity. And then comes the biosensors, devices that detect and transmit information regarding biological processes such as glucose monitors. So some of these devices, I have shown the diagram over here. And what we do with this collected data, heart rate. The one of the collected data is the heart rate. So variability can indicate stress levels of cardiovascular health. So sometimes now, if you can see that the newly found wearable devices and apps, it can even recommend, okay, your heart rate is actually failing. It is not good. You need to see a doctor. Activity levels, data on movement, intensity, and duration contribute to understanding physical fitness. So, activity levels, suppose you are a person who usually do exercise very regularly, and suppose for 1 week you have slowed down, then it will give you a warning that your activity has come to a slow rate, it will affect your health. Such kind of warning messages you might be getting from the apps. And the sleep patterns also, information on sleep duration and quality is vital for assessing overall health. And skin conductance measures set gland activity, which can be correlated with emotional arousal. Temperature, body temperature fluctuations can signal metabolic changes or illness. Blood oxygen levels indicates respiratory efficiency and detect conditions like sleep apnea. So these are some of the health uh, parameters which is monitored by your smart wearable devices, which finally indicates or assess your mental health. And even the data sources, which is as the online platform, social media activity, whatever posts you are sharing, your likes, your shares, your online search history, online transactions, forum participations, and even your frequency and content of posts, it can reflect your mood. So whenever, usually when you are sad, what you will do? You will put some, maybe if you are angry, you will put some angry message on your social media or your social engagement and interest. And search history, whatever your queries can indicate the concerns. What are the different data collection methods now for the digital phenotyping purpose? There are passive data collection as well as active data collection. Passive data collection means in the background which is going on, background data collection continuously monitoring. And active data collection is the one, maybe you are answering to some surveys, some questionnaire, some ecological momentary assessments. So, and then comes the data prep. Once the data is collected in your smartphones or smart wearable devices, what is it being done? So, the data pre-processing and feature engineering is the step. You will be cleaning the data cleaning, handling missing values, noise, outliers, then data transformation, that means you are going for the normalization and scaling. Then the feature extraction, statistical features, time series analysis, and frequency domain analysis. So I have given an image here. It's a diagram depicting the data pipeline showing raw data entering, being cleaned and transformed, and then having features extracted. What are the different algorithms in digital phenotyping? So there are many algorithms. The common algorithms like machine learning models, natural language processing, signal processing techniques, deep learning networks. These are some of the techniques or algorithm which is used in digital phenotyping. And machine learning for digital phenotyping, that is the image I have already shown here. General in ML flowchart is given, supervised learning, classification and regression, and supervised learning. And this is the diagram of a standard machine learning flowchart showing data input, model training, and output. So here you can see You have may you have unsupervised data, supervised data, new data. The feature extraction is done, and the machine learning algorithm is applied, grouping of objects, or and finally you can even predict the model and that we can analyze or annotate the data. So how common algorithms which include the time series analysis, and you have the recurrent natural neural networks, LSTMs. The applications of these algorithms are predicting future behavior. So this is what is being used after collecting the data from your wearable devices, identifying patterns in activity recognition and even mood prediction. So by analyzing the usage of apps in a mobile phone, or analyzing the usage of your laptop, your iPad or iPhone, or even your other devices, electronic gadgets. So it can even predict the digital phenotyping techniques. It can say that it can predict your mood. So here what I am included an image is a simplified diagram of an LSTM network highlighting the recurrent connections and memory cells. Then there are some algorithms are used for anomaly detection. If the person who is using the smart devices, suppose if his behavior is out of the usual behavior. So for that, you have the anomaly detection algorithms like isolation forest, one class SVM, local outlier factor. And the applications of this particular algorithms are, you can say that detecting unusual behavioral patterns that might indicate a problem. That means a sudden change in activity levels or unusual communication patterns. Another common algorithm is clustering, K-mix clustering, DB scan, hierarchy clustering, all this can be used. Grouping users based on similar behavioral patterns, identifying subgroups with their population. So here I have what image I have shown as a scatter plot with the data points colored according to their cluster assignments. And what are the different existing approaches? Because the digital phenotyping, the concept was introduced in the year of 2010. From there onwards, there are so many different approaches, so many different methods which is going on. So the digital phenotyping currently employs smartphone sensor data analysis, social media behavior analysis, voice and speech analysis, movement and mobility tracking. So these are some of the existing approaches. And it comes to mental health applications, where exactly you can use the digital phenotyping and even your behavioral biometrics applications. So depression, this can be used for depression detection. You can use it for monitoring behavioral changes, which is indicative of all mood disorders, and detecting early signs of anxiety or depression. And you can even suppose if any person is of bipolar disorder management, so that can be done, and so that you can provide the doctors, the psychiatrists, with the continuous behavioral data for better treatment plans. And even you can even use this particular data for early detection of suicidal ideation. And behavioral biometric applications can even use for user authentication uh, by through typing and swipe patterns, identifying anomalies in behavior that may indicate distress or cognitive decline. So, despite their potential, the sheer volume and sensitivity of the data which is collected pose challenges related to data store. The challenges of which comes into is the data storage and maybe the security or the encryption and access control. So the unauthorized data access or manipulation can lead to inaccurate assessments and severe consequences for users. So these are some of the how it is being done. So biochemical screening or voice analysis or activity and movement, electronic agenda questionnaire, sleep monitoring, biopsy. So this is one whom I have shown is a patient. From the patient, these are the different parameters, different things collected by, and this particular data is being processed. You have a processing unit over here and the server technician data processing. Then by using this, the remainders messages can be sent by the doctor, the physician, to the patient. This is another way of understanding the physical or activity levels. So I have reviewed many different existing work and papers, and it actually some of the works which I have reviewed doesn't directly address the connection between digital phenotyping and mobile security, but there is a potential for digital phenotyping that could be used to enhance mobile security by incorporating behavioral patterns into user authentication. So we can actually, this collection of data and incorporating more secure mechanisms into the smart or wearable devices, it can create a dynamic security system that adapts to individual user habits, potentially addressing the limitation of our static biometrics. So the physical health applications, usually what we are using as activity tracking, sleep monitoring, chronic disease management, for example, diabetes and heart disease, medication adherence. And the examples are related to fitness, a healthy meal or a sleep, a person sleeping peacefully, and health monitoring. So then comes to the leaving the digital phenotyping aside, then comes to the next part, that is the behavioral research. So behavioral research is the one which allow us to study or do more research into social interactions, mobility patterns, and communication patterns, or even the decision making. So this is using this behavioral search or behavioral biometric research. You can say that there are so many tailoring inventions based on individual behavioral patterns and needs. So here, if your smart device is connected to your mobile, you can anytime you can get personalized nutrition suggestion or personalized exercise plans, or even you can get the mood management techniques. So literature study that have focused on mental health monitoring and chronic disease management and behavioral prediction, which is already I have done. And the key findings suggest that high accuracy in detecting mood disorders using the digital phenotyping. That is what we have identified. So there are so many different features I have gone through. So the security, behavioral biometrics is vulnerable to mimicry and the context dependent. And when it comes to talk about physiological biometrics is generally more secure, harder to spoof. And when it comes to the privacy concerns, behavioral biometrics is actually less intrusive. We cannot even as such we cannot intrude into the data of which we collected through the behavioral biometrics. That is, data is often already collected. And then the physiological biometrics, when it concerns, it is more intrusive, requires specific data collection. And behavioral biometric, the example for behavioral biometrics is typing speed and maybe the swipe pattern. And when you talk about the physiological biometrics, the fingerprint, your facial recognition, your iris scan, these are some of the features which we collect. And we can even, this is one of the field you can do a lot of research. That's what I understood by doing the literature survey. So how can a digital phenotyping data which is collected from the smartphones and maybe from the wearable devices, how can this be integrated with the existing mobile security protocols? There are a lot of mobile security protocols, right? So how can you integrate these data which you have collected through this, and how can you create a more robust and personalized user authentication system? When it comes to the security and privacy implications, actually there are new different kinds of risk. So these are some of the papers I have gone through. And what I understood is there is data privacy risk. So sensitive mental health data, if you are sharing, if it is out, if it is in what you call in the World Wide Web, it can be exploited if accessed by unauthorized parties. And robust encryption protocols, secure APIs, and anonymization techniques has to be implemented to safeguard this particular sensitive mental data. And there can be threats, data manipulation threats. Malicious actors could manipulate the behavioral data. Right. It may lead to the identity theft. It can lead to false assessment. So in this particular case, what we can do is AI-driven anomaly detection can help identify irregularities in data patterns. And device compromise risk. Mobile devices are very much vulnerable to malware, phishing attacks, and hardware level vulnerabilities. So regular security updates and multi-factor authentication mechanisms are very much needed in the case of if you are using the mobile and smart wearable devices. And what are the different mitigation strategies in this? So you can go for data encryption, you can use access control mechanisms, you can have some AI ML driven security models, you can give awareness to the users, or you can put some ethical guidelines. So what are the different, I have already mentioned what are the different proposed methodologies. There are so many different data sets available if you search in net. I'm not sharing all those things over here. So what are the different current work, existing work, or you can say that ongoing works? Research is expanding in areas like mental health or monitoring, chronic disease prediction, personalized healthcare recommendation, and real-time behavioral interventions. And there are organizations supporting digital phenotyping as well as the behavioral biometrics techniques. These are some of the famous organizations, that is Harvard University, Mindstrong Health, Verily Life Sciences, MIT Media Lab, World Health Organization. So these are some of the organizations which supports the digital phenotyping. And the future directions involve privacy preserving data collection, integration with the telehealth, enhanced machine learning algorithms, and even global health applications. So our what we can do after collecting the digital phenotyping data from the smart devices or wearable devices or mobiles or laptops or even from the social media, we can develop a novel mobile security approach which improves the digital phenotyping data. You can go for improved security and reduced vulnerability to attacks. You can have an enhanced user experience through personalized authentication. You can give insights into the potential of digital phenotyping for applications beyond mental health. So some of the data, while I was doing my research, some of the data which I received was from the mobile user interaction data database. And there is another data set from wearable sensor data I have selected from the M Health organization. And I got some data from mobile health data collected from MD2K. So those were some of the areas which I have selected. And I would like to show a part of my work which I have collected some data from. Okay, just a second. I will show some of the data which I have already collected. That's 2 minutes. 2 minutes. I'm coming. So are you able to see my screen now?
Yes, ma'am.
Yeah. So these are some of the data I have collected. For the purposes of this, exactly the which one I was talking to you about. So the data that I was able to get some of the data and the mean of sensor readings and proportion of activity labels, which I was able to find out. And the biometric analysis, which I have done, and activity distribution, So these are this is the way people are collecting the data. You can even see the user ID, the device model, the what kind of devices I have collected. This is around more than 6,500 data, and which is identifying the operating system, the usage of the particular app usage, and screen time, how much battery is being left, number of apps which is on during while you are using the, and even the gender of the person, how the person using the data, I mean the smart wearable devices, and the user behavior class. So this particular data set was having 700 entries and 11 columns. So it was providing all the detailed information which was required. So if suppose if it is coming, if this data is getting into a person who is not supposed to get the data, then what can happen? That is the main problem, main discussion over here. The security implication of getting such data in the wrong hands. So I have done some evaluation of encryption algorithms on mental health data sets. So again, this is some of the graphs I have plotted using that, and some of the I think I got accuracy for 100% accuracy, 100% precision. That means the data which I received from different databases, either it is overfitting or it is a fake data. I should not be getting accuracy of 100% or precision of 100%. Everything it is 100%. So something has gone wrong with the data which I have received. So here, as I have mentioned before, the privacy breaches are sensitive personal information. On these particular data, there could be, you can say that privacy breaches can happen, and it may lead to identity theft or exploitation. And this can lead to even this private data. If it is getting collected at some particular databases, what happens is it can lead to behavioral profiling. So detailed analysis of your app usage and screen time and activity levels can be used to create behavioral profiles. So these profiles can be misused for targeted advertising, manipulation, and even for discrimination. So this is what I have written, some of the things. I think this being a social human being, we need to have some ethical concerns. The manipulation of user behavior should not be allowed. Bias and discrimination should be discontinued. And these are some of the mitigation, how to handle this. So data minimization, collect only the data which is necessary for specific functions. And whenever you are collecting the data, you need to have the get the consent from the user, and the whatever data you are collecting with the consent of the person should have some transparency. And the data which you have collected, the private data, the sensitive data which is being collected, should be encrypted and used, secured, stored securely. And the limited access only should be given to the sensitive data through role-based access. And regular security audits has to be performed. So, and anonymization and differential privacy is to be introduced in compliance with the privacy laws, like in Europe, it is GDPR and CCPA, and these are some of the complaints. So I would like to conclude my topic here. While data collection can drive valuable insights and innovation, it carries significant security and privacy risks. So organizations must implement robust safeguards to protect user data, ensure ethical usage, and comply with legal frameworks. So failing to do so can result in severe consequences for both users and companies. So with this, I would like to stop my today's topic. Once again, I thank IoT Academy and the Huawei Kalamagal College for giving me such an opportunity to talk to a lot of audience today. Thank you.
Thank you, ma'am. We would like to invite Mrs. S. Narmata, Department of Computer Applications, Kovai Kalamagal College of Arts and Science, to deliver the vote of thanks.
It's my privilege to propose a vote of thanks. I would like to thank the experts for taking their precious time out and making to this event successful. I would want to thank my audience for being present here today. It has been such an honor to be a part of this wonderful event. On behalf of the organization, I would like to thank our secretary, Dr. K. H. Chinnaraju sir, and our principal, Dr. N. Mala, and principals from other institutions. I would like to extend my heartfelt gratitude to our esteemed guest, Dr. Siju George, Associate Professor, School of Computer Science and Engineering, Christ University, Bengaluru. And I thank to Dr. Asha Joseph, Professor and Dean, MBJ College, Engineering, Bangalore. I would like to thank to the head of the various departments, faculties, and participants who handled the event throughout. A wide round of applause and thanks to all the participants who made the event successful. Finally, I would like to thank all you present here for making the time to be with us today and helping us make this event a grand success. Thank you. Thank you to one and all.
Thank you, ma'am. On behalf of Covey Kalamagal College of Arts and Science, Coimbatore, in association with IoT Academy, we would like to extend our heartfelt gratitude to our esteemed resource person, Dr. Asha, for taking the time to share her valuable insights and expertise with us today. We are grateful for your willingness to share your knowledge and experience with us, ma'am. We thank you very much for your efforts, ma'am. We thank the faculties of Covey Kalamagal College of Arts and Science and participants joined here for joining the session today. Kindly subscribe to our YouTube channel with the link that has been posted in the chat box for regular updates. Thank you all. Have a great day and thank you for joining us.